So let's take a look at this homework for graphing linear inequalities and systems. So just more practice with graphing. So just remember, it's just like any team, any sport, any sort of thing that you compete at, you're going to practice. And you're going to do the same things over and over and over to get better at them. So that's all this is, 24 questions of just practice over and over. So try these first. My suggestion, if you're really struggling with this, watch a problem, then do another problem, then watch it, then do it, then watch it, then do it. If you think you got it down, try them all, then watch this and just check your answers. Okay? So, let's start. Now, slope-intercept form, but there's no plus 0, right? Well, we can add the plus 0, but they don't have it. So we start at 0, 0. Okay? Our slope, positive 1 over 4. So positive, we go up and to the right, or down and to the left, because we got to be going in this direction. So we're going to go up 1 to the right 4, or down 1 to the left 4. Now we check solid or dotted, no equal to. So we're going to go with a dotted or dashed line, whichever you want to call it. Now we can't pick the test point 0, 0 here, can we? So let's think about this. I want to pick a point for my x where that 4 is going to get rid of it, because I don't like 4s. So I want an x value of 4. So why don't we do an x value of 4 and a y value of 0? So it'd be, the test point would be 0, 4. Not 0, 4, 4, 0. Okay, so it's on the bottom. It's under the graph. So 0 for y is greater than 1/4 times 4 for x. Well, 1/4 times 4, timesing by 4, dividing by 4, they cancel. We're left with 1. Is 0 greater than 1? No. So we shade the top side. Okay, that's when you're picking one without the 0, 0, that's all you got to do. Okay, number 2. Plus 3 for our y-intercept. Slope of 2, make it a fraction, 2 over 1. Positive 2 over 1, so we're going in this direction, so I can go up and to the right or down and to the left. So up 2 to the right 1, run out of space here, so down 2 to the left 1. And we can keep going on that. Then we look, is it solid or dashed or dotted? Okay, no equal to, so I know it's dashed or dotted, whichever you want to call it. I guess dashes are probably easier to do. Then pick our test point 0, 0. 0 for y, 0 for x, and we solve. This is 2 times 0 is 0, plus 3 is 3. Is 0 greater than 3? No, it is not. So we shade on this side. Okay? And that's all we're doing here. So plus 2, y-intercept of plus 2. Slope of x, so we think of it as a 1x, make it a fraction, 1 over 1. It's positive, so I know I'm going in this direction, so up 1 over 1, and up 1 over 1, or down 1 to the left, down and to the left. So, draw my points. Okay, it's a solid line, because it's got the equal to. Pick our test point 0, 0, 0 for y, 0 for x. 0 plus 2 is 2. Is 0 less than or equal to 2? It is. So we shade the side that the x is on. That's part of our answer, remember. That shaded part represents every possible answer, because with inequalities we have more than one answer. We have this whole region that's a possibility. That'll work. If I want to know, pick any one of these points out here, put them in my inequality, and it'll work. Okay, number 4. Positive 5, start at positive 5. Now we've got a negative slope, so I know I'm going down. So I can go down 1 and to the right 5, or I can even go up and to the left to maintain that same pattern. So there's a point, there's a point, there's no equal to, so draw a dotted or dashed line. Dashed lines look a lot better, I think. Pick our test point 0, 0, 0 for y, is greater than negative 1/5. 0 for x, plus 5. Well, we know that cancels, so is 0 greater than 5? Nope. So I shade the little itty-bitty part above it. Technically, it just keeps going, but that's the part we shade. Alright, we're moving right along, right? Okay, let's just keep at it. -3, so just all this practice. See, you're just getting lots and lots of practice. positive slope, so I know it's going in this direction. So I go up and to the right, up 1 to the right 2, or down 1 to the left 2. Okay? So up 1 to the right 2, down 1 to the left 2. There's no equal to, so I know it's dashed or datted. Dotted or dashed. 0, 0, 0 for y, 0 for x. We know 1/2 times 0 is 0. 0 minus 3 is negative 3. So this 0 comes down, inequality comes down. Is 0 greater than negative 3? Yes, it is. So we shade up here. Okay, number 6, positive 3 for y-intercept. Slope of 3, make it a fraction. It's positive, so we know we're going up 3, so we're going to go up 3 to the right 1, or down 3 to the left 1. So it's kind of a steeper one. There is an equal to, so we draw our line. Okay, pick our test point 0, 0. 0 for y is less than or equal to 3 times 0 for x, plus 3. Well, that's 0 plus 3, so that's 3. Is 0 less than or equal to 3? Tis. So we shade that side where 0, 0 is on. Those are our answers. Okay, now we got some in a different format, right? But we can still deal with these guys. Remember, all we got to do is rearrange it. So I can subtract an x from both sides. So I'd have negative y is greater than negative x plus 2. Now we've got to remember that when we deal with, because we're going to have to divide by a negative number here. So when we divide by a negative, that becomes positive y. That inequality has to change direction. That becomes a positive x. That becomes a negative 2. So we go down 2, now that it's in slope-intercept form. Think of that as a 1. Make it a fraction. It's positive, so I know it's going this direction. Up 1 over 1. Or down 1 to the left 1. So up 1 to the right 1. Or down 1 and to the left 1. There's no equal to. So kind of fill in my line, my border. Pick my test point 0, 0, and I can start it. I can put it in this one. Go 0 minus 0 is greater than 2. Is 0 greater than 2? No. So we're shading down here. Or I could keep it in this one and go 0 is less than 0 minus 2. Notice we basically have the same type of thing going on. Okay? So number 8, same idea. Subtract the 2x. We get just a positive y is less than or equal to negative 2x plus 4. Notice I don't have to divide by a negative, so I just leave it how it is. Okay, so up to positive 4, make that negative 2 over 1. So it's negative, so we know it's going down somehow. So we're going to go down 2, because that's on the top, to the right 1. So down 2 to the right 1, down 2 to the right 1. Or remember, we can go up 2 to the left 1. Now, solid line, because it's got an equal to. Pick our test point 0, 0. 2 times 0 plus 0, is it less than or equal to 4? Is 0 less than or equal to 4? Yes, it is. So we shade the side where 0, 0 is. And it's right there. So we shade this side. Alright. We blew right through those ones, didn't we? Okay, we got 2 more just like that. So if you haven't tried them on your own, please try them on your own now. Pause it, try it, see where you get. So we'd subtract 5x from both sides, right? Giving us 4y is less than negative 5x minus 20. Divide by 4 on everything. We get y is less than negative 5 over 4. Leave it as a fraction. 20 over 4, negative 5. So a negative slope and a negative y-intercept. So we start here. Then we know we're going to go in this direction. So we go down 5 to the right 4, or up 5 to the left 4. Okay, so start at -5. We can't go down really well, so let's go up. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, no equal to, so I know I've got a dashed line here. Pick my test point 0, 0. 0 for y. 0 for x. That becomes 0. 0 minus 5 is -5. Is 0 less than -5? No, it is not. It is greater, so we shade the opposite side. Now notice sometimes I'm using the original equation for my test point, sometimes the new one. You can do whichever one you want to. I'm just showing you that it works regardless of which one you do. Okay, number 10. Subtract 3x from both sides. Now that negative stays with that 4, so we get -4y is less than or equal to -3x plus 12. Now we divide by -4 on everything. That becomes y. Now because we're dividing by a -4, that inequality has to change direction. Negative over negative makes a positive 3/4 x. Positive over negative, 12 divided by 4 gives us a -3. So we start out at -3. Then it's positive, so we go up, right? Up and to the right or down and to the left to maintain that same pattern. So I can go down 3 to the left 4, or I can go up 3 to the right 4. There is a line underneath it. It is equal to, so I draw my line. Pick my test point 0, 0. 0 for y. 0 for x. Plug it in. That becomes 0 minus 3. 0 minus 3 is -3. Is 0 greater than -3? It is, so we shade the side 0, 0 is on. And remember, guys, if you choose a different test point, you put in different numbers here. You still solve it, you still simplify it, and see if it works, but you just put in different numbers. All right, whew. We done with these inequalities? Okay, good. About done with inequalities. Okay, so subtract 4x from both sides. That gives us a positive y is less than -4x minus, or plus 1 because it's positive 1. So up to positive 1, make that a fraction. It's negative, so we know we're going down. So down and to the right or up and to the left. So down 4 to the right 1, down 4 to the right 1, or up 4 to the left 1. No equal to, so it's dashed. Pick our test point 0, 0. Still could work. Why don't we pick a different one just because it's kind of close? So let's pick -2, -2. So I put -2 in for y, -2 in for x, plus 1. Negative times a negative is a positive 8, plus 1 is 9. Is -2 less than 9? Yes, it is, so we shade the side where -2, -2 is. Alright, now number 12, notice we don't have an x here. Remember, if you have x is greater than or less than or to a number, or x is equal to a number, that's going to be a vertical line. So if it's just y, that's going to be a horizontal line. So we look at 3, our y-intercept of 3, that's where we draw our line. Now, it's not equal to, so we draw a dashed line here at 3. And then is y bigger or smaller? Well, it says y is greater. Greater would be above for the y value. Less than would be below. If you want to check that, pick a point 4. Is 4 greater than 3? Yes. Pick a point 2. Is 2 greater than 3? No. So we shade above. Those ones are the easy ones. Alright, now let's shift gears in our minds and think about solving a system. Okay, so now we're not dealing with inequalities here. We're dealing with a system. So we simply graph both of them. See where they intersect. That's where our answer is. So first one, -1. Slope of 2 over 1. So up 2 to the right 1. Right, because it's a positive slope. Or down 2 to the left 1. It's equal, so we draw our line. There's our first line. Now we do the second one. Positive 3 to start us off. Y-intercept, slope -2 over 1. So negative, going down that way. So I go down 2 to the right 1, and I see right where they intersect already, don't I? So I don't need to do any more of that. Pick that point. It's 1, 1. So that's my answer. Remember, we're trying to get the answer as a point. What x value and y value on this graph satisfy both. Now I could take those and plug them in for y and for x and solve them and see that they do work. See, works for the first one, 1 for y, 1 for x on the second one. Works for the second one. Okay? You don't have to check it, but you can if you want. Now let's take a look at 14. So y equals negative x minus 4. So start at negative 4. Slope of negative x is like negative 1 over 1. So we're going down. So I go down 1 to the right one, or up 1 to the left one to keep that same pattern. Draw my line. Okay, then we look at the second part, positive 4 this time. Slope of 3 over 1. It's positive, so we know we're going this direction. So we're probably going to intersect somewhere over here. So I go up 3 to the right one, or down 3 to the left one. Oh, we were a little off. But same idea. Okay, pick our test point. Negative 2, or test point. Wow, now I'm really going to screw up, aren't I? Pick our point where they intersect. That's our answer. Negative 2. Okay, so that's systems. So make sure you're trying these on your own first, and then taking a look at them. Now, you should notice something right off the bat about number 15. We've got different y-intercepts. So I positive 2 for one, negative 2 for the other one. But now notice their slopes are exactly the same. So they're both going to be going that positive direction at the same rate. We go up 5 and to the right 4, okay, or down and to the left. So when we have that same slope with a different y-intercept, we're always going to be maintaining that same distance between them because they're parallel. So when they're parallel, there's no solution. They never intersect. We know that because they have the same slope, different y-intercepts. Alright, 16. Positive 1, slope of 2, that's like 2 over 1. So positive, so up and to the right, or down and to the left. So down 2 to the left 1. Remember, it's a good idea to draw as many points as you can on the line. So, positive 4 to start us off, negative x, that's like negative 1 over 1. So we're going to be going down. So down 1 to the right one, or up 1 to the left one. We see where they intersect. Right here, at this point, 1, 3. That's our answer. So there's one answer. So sometimes you get no solution. Sometimes you get one answer, and it's that point. And sometimes you get a third answer, which we'll see in a bit. Okay? So, negative 3. Slope of 1 over 1, right? Because it's just x, so up 1 to the right one because it's positive. Or down 1 to the left one because it's positive. There's our first line. Now our second, positive 2. Make that a slope of negative 4 over 1. It's negative, right? So we're going this direction. So we go down 4 to the right 1. Down 4 to the right 1. Draw our line. We see exactly where they intersect at 1, negative 2. X value first, y value second. One answer. And what's that answer? 1, negative 2. That's where they both are equal. Okay, number 18, positive 3. Slope of x, so 1 over 1 again. So up 1 to the right one because it's positive. Or down 1 to the left, so we're going in that positive direction. Going up. Okay. The second one, negative 2, start at negative 2. It's got a negative slope, negative 4 over 1. So I know I'm going down 4 to the right one, or up 4 to the left one. You see where it intersects. That point, negative 1, 2. Okay? So just like that. With these, we're just like that. Okay, let's actually leave this down here now. So now we're dealing with standard form. Okay, so we just change it. So subtract 4x from both sides. We get y is equal to negative 4x plus 3. So up to positive 3, negative 4 over 1. So down 4 to the right 1, down 4 to the right 1. Draw our line. Okay, same idea here. Subtract 4x from both sides. We get y is equal to negative 4x plus 4. What do we notice here? That we've got parallel lines, don't we? Same slope, different y-intercept, so no solution. Often when you change them to slope-intercept form, you can see that right off the bat. You don't even need to graph it usually. Okay, 20. Subtract the x. We get negative 4y equals negative x minus 8. Remember, when it's minus the y term, it stays negative. Divide by negative 4. And we get y is equal to negative x over negative 4 would be positive. Think of it as 1x, so it would be 1/4 x plus, because negative over negative, 8 divided by 4 is 2. So positive 2. Slope is positive 1 over 4, so up 1 to the right 4, or down 1 to the left 4. There's our first line. Second one, we'd subtract 3x from both sides. So negative 2y, that negative stays with us again. Negative 3x plus 6. Divide by negative 2. Too many of you make that issue without me having to make it harder. Negative over negative makes it positive 3/2 x. Positive over negative is negative. 6 divided by 2 is 3. Start at negative 3. We've also got a positive slope, so up 3 to the right 2. Up 3 to the right 2. We see where they intersect. Right there. So it would be 4, 3 for our answer. Okay? Almost done, guys. Almost done. So, let's take a look now. (21). So subtract 5x from both sides. Remember, we're just getting practice here. Same stuff over and over, and I know it seems repetitive, but that's the point. So you get better at it. Okay? And I can give you a problem and you can do it. So negative 4, slope of negative 5 over 1, so we've got to have a negative slope here. We can't go down 5, so we'll go up 5 to the left 1. Okay? So up 5 to the left 1, up 5 to the left 1, somewhere about right there. There's our first one. Okay? Then we subtract 3x here. That negative stays with the y, so negative y equals negative 3x minus 4. Divide everything by negative 1. We get y equals positive 3x over 1 plus 4. So up to 4. Now it's positive, so we know it's going in this direction. We can go up 3 to the right 1 or down 3 to the left 1, and we see right off the bat where it intersects, even though my line wasn't the best. That's why you draw as many points as possible, because you can see better where you're going to intersect. So we got one answer at negative 1 over 1. Okay, now 22, same idea. Okay, to get y by itself, just divide everything by 2 on the first one. So we get y equals 3/2 x minus 2. So down to negative 2. It's positive, so we know we're going in that direction. So up 3 to the right 2. Or we can go down 3 to the left 2. Draw our line. Okay, now we do the same thing to this. Let's add a 6x because it's a negative 6x. So we get 4y equals 6x minus 8. Divide everything by 4. And we get y equals 6 over 4 reduces to 3 over 2. X minus 8 divided by 4 is 2. What do we notice right off the bat? We've got the same exact line. So here's our third type of answer with systems, and that means it's always intersecting, so we have infinite solutions. I also accept many solutions. Same thing. Same thing in my book. Alright, so now 2 more problems. Now we've really we've combined graphing inequalities and systems. So now we're dealing with the system of inequalities. Okay? So looking at this, what do we need to do here? Well, we need to graph them both on the same line, and we need to shade them. And then where do you think the answer is going to be? That's the question. So let's graph them. So, positive 1. slope of 1 over 1 because it's just x. So up 1 to the right 1 because it's positive, so it has to be rising, or down 1 to the left 1 because we're still maintaining that positive slope. Now there's no equal to, so we draw a dashed line. Pick our test point 0, 0, 0 for y, 0 for x. Is 0 less than 1? Yes, 0 is less than 1, so we shade this side. Okay, now let's take a look at our second one. So negative 3 for our y-intercept, negative 1 over 1 slope. So now we've got to have that opposite slope. Okay, so we're going down 1 to the right 1. So it's negative, or up 1 to the left 1. Okay, we see where they intersect, but that intersection point isn't so critical here. There's no equal to, so a dashed line. Okay, that's not our answer here on this one. Because, honestly, they're both dashed lines, so that intersection point isn't the answer. Okay, because that's not part of our answer for either of them. So let's pick that test point 0, 0 again. 0 for y, 0 for x. Negative 0 minus 3 is negative 3. 0, is it greater than negative 3? Yes. So we shade this side. So now my question is, where is the place on this graph that answers the question, the solution for both of them? Well, remember with inequalities, the solution is where it's shaded. So we're looking for the place where they're both shaded, which would be that section right there, right? That's the solution here. Just like with a system of equations, the answer is where they both meet. With a system of inequalities, the answer is where they're both shaded. Okay? So you're looking, this is where there's no answer. This is where there's half the answer, that section, and that section. But this is the place where we have our full answer. Alright? So try 24. Okay, so positive 3. Hopefully you try it on your own first. Slope of 2 over 1, it's positive, so we're going in that direction. So up 2 to the right 1, or down 2 to the left 1 to maintain that same pattern. There's no equal to, so it's a dashed line, so our line isn't part of the answer, it's just the boundary. Okay, negative 3, start at negative 3. Oh, I forgot to shade. Oh well, we'll get there. Negative 4 over 1, we go down 4 to the right 1. Or up 4 to the left 1. See where they intersect, but that's not necessarily our answer. Okay, that could be part of the answer. This one's equal to, so it's a solid line. But now we've got to figure out where everything needs to be shaded. So let's pick that test point 0, 0. So let's do this one first. 0 for y, 0 for x. Negative 4 times 0 is 0. 0 minus 3 is negative 3. Is 0 less than negative 3? No, so the green side we shade over here. So I know my answer is going to be either this section down here or this section up here, right? The blue line is going to determine that, where it's shaded. So 0 for y, 0 for x. That would be 0. 0 plus 3 is 3. Is 0 less than 3? Yeah, so we're shading this direction on the blue. So the possible answer could be right here or right here, but where are they both shaded? Got it. Right there. So that is our solution. And there we go with a system of inequalities. Remember, it's just combining systems and inequalities together. And we'll talk more about this later. I just wanted to introduce that to you on the homework.